All right, today I'm going to take you through the DESMOS activity that we've assigned through your hyperdoc, and it's about quadratic equations and looking at the graphs. I'm on screen 10 of your student assignment. It says adjust the slider so that the parabola passes through the blue points. So if I take a look at my picture, I have 4 blue points that are graphed for me. And if I take a look at that, it sort of looks like maybe it's an arch going upwards to me, because as you do your parabolas, the closer it gets to your vertex, the more narrow your graph will be. So the more narrow points are at the top here. So that tells me my graph should be going up and then down. So when I take a look at my sliders, if I press play, it's showing me movement of my parabola. And what it's showing me is the different numbers that can be applied to change the direction of my parabola from up to down. I'm going to pause it there. So yeah, I definitely want it pointed downward. And then I'm going to take a look and see. This one looks to be pretty narrow. So I'm going to just kind of make it a little bit wider as like an estimate to see. Maybe right there, maybe at -2. That kind of looks like it might match my parabola. Now, my parabola is not quite perfect. I'm going to take a look at my y-axis and see if I have any y-intercepts. And I do down here at -4. In my equation of a parabola, for my quadratic form, the y-intercept is at the back of the equation at c. So if I look at my y-intercept, it's at -4. So I'm going to go ahead and move my slider to -4 because I know that's where it's going to intersect. So I'm getting a little bit of a shape of my parabola here, but now it's not in the right spot. It has to move up and over quite a bit. So that's the B part. So I'm going to go ahead and play that and see where it looks like it's moving. I'm going to kind of hit stop where I think. Here it comes. Maybe there. Okay, so it's not quite in my position. And what I'm noticing is that this green line here is my axis of symmetry. And so that should be the reflection line. So when I take a look at my y-intercept, if I were to reflect it over that green line, it's going to be right here. But the point I need to make is a little bit wider. So this isn't quite my axis of symmetry. So I'm going to go ahead and bump it maybe to 8 and see. Oh, there we go. It matches lovely. Okay, so that's example 10 on your DESMOS activity. The next one we're going to take a look at is number 12. So number 11 on your DESMOS activity just says the points on the previous screen were given to help you determine the line of symmetry. And there we've got it. Our line of symmetry is going to create a mirror image for all of the blue dots that they've put on the class. All right, here's number 12. Again, I have some blue dots here. They're quite wide. But I do know that the blue dots should be a reflection of themselves. It also looks like maybe my shape is going in this direction. So I know it needs to be concave up, which means I need a positive A. So if I just keep moving it up this way, is getting more narrow. I need it to be wider. I'm going to, oh, that's flat. Let's see. Maybe there. That looks like as wide as I can go without it changing to flat here. All right, the next thing I want to see is where my y-intercept is, and my y-intercept is right up at 1. So that means for C in my equation, it has to equal 1. So I'm going to move my slider there. Now the whole thing has to shift down and to the right. And when I take a look at this, I'm looking for that axis of symmetry. And I'm going to use my 2 more narrow dots. It looks like if I move over 1, 2 spaces to the right, or from this dot, if I go 1, 2 spaces to the left, I'm going to hit my axis of symmetry. My axis of symmetry, therefore, should be at x equals 4. So we're going to go ahead and play slider B. and see where it needs to go. So over to the right, it looks like it's going in the wrong direction, but to the left, it's going in the right direction. So I'm going to just, oh, I paused it right where it needed to go. And that's at B at -2. So there you have your new graph for question 12. One point on the previous screen was given to help you determine the C term. What point was that? And that's this point right over here. Y equals 1. That's your y-intercept. And y-intercepts determine point C. We'll take another look at number 14 real quick. It says adjust the slider so the parabola passes through the blue points. I don't have a mirror. I don't have opposite points over here on the right side, so I'm going to have to use a guide. I do have one. Okay. Let me zoom in a little bit more and slide my graph maybe. We'll see. Nope, that's probably too much. All right, we'll leave it at this. So it looks like in between -3 and -2 is where my axis of symmetry should be. And it's probably, I'm going to take a guess, right at -2.5. I think that's where my axis of symmetry is. If I take a look at this point and try and reflect it over, it's not quite my y-intercept. So I'm going to take a look at this point. I'm guessing this is my y-intercept. So if I reflect this point over 1, 2.5, let's see, 1/2, 1 and 2, I think that's going to be my y-intercept. So I'm thinking my C has to be at 2. I'm going to go ahead and move my slider over there at 2. It does look like it's a positive curve. So I'm going to just kind of leave it the way it is right now, and I have to play my B and see if that's going to change anything. So I'm going to go ahead and play it, and then I'm going to go ahead and pause it. Okay, so that's not quite it. So if I keep moving my slider, there we have our graph. I've got all of my blue points hitting. And that means my A, my coefficient, is 1 because this is concave up. The B is at 5. That's the coefficient of x. And my y-intercept is at 2. Take a look at 15 and see what it says. Oh, this is a brand new problem. So hopefully that helps you figure out how to use the DESMOS activity as you're moving on. It's really just for you to see what changing those constants and coefficients can do to the parabola. Okay, your coefficient of A determines if it's concave up or down. Your coefficient of B, along with your coefficient of A, are going to help you figure out that axis of symmetry. Remember, that's a reflection line. So if you have a graph, you're looking for all the points to be equidistant from a certain vertical line. That's your axis of symmetry. And lastly, C is your y-intercept. So you want to look for that point on the y-axis, and that's going to be your C. So for this example, our C is at -4. I'm going to go ahead and drag my slider to -4. And I'm looking at my points, and to me, they look like they go up and then down. So I know my y-intercept, my coefficient of A should be negative. So I'm going to just kind of do that. And then I'm going to play my slider for B and see if I can make it stop where I want it. And there you go. This looks like it. My my axis of symmetry goes through the x-axis right at 3.